Lesson 9.3 is all about graphing rational functions. Now, there's a difference between a rational function and a rational expression. Here we have a rational expression, x over x plus 1. This is an expression because there is no actual equal sign. We're just stating something. Here's a value, x over x plus 1. If we were to say, though, f of x equals x over x plus 1, now there's an equal sign in there and has become a function. So the difference is that there's that f of x equals portion that creates it into a function versus just an expression. So again, a rational function then is a fractional function in which the numerator and denominator are both polynomials, meaning both have a chance to have variables. Not all of them have a variable in both. Now in this one, we have f of x equals x squared minus 4 over x plus 2. We know how to simplify this. We can factor it out into x plus 2 and x minus 2 over x plus 2. Now we might not know how to graph that right away, but notice how we can take out this common factor, x plus 2. So we would say then that this rational function is going to look just like the function y equals x minus 2. And it does. Here's our y-intercept, negative 2. Essentially we have a 1 as our rate. So up 1 over 1, up 1 over 1, up 1 over 1. So this is what our line looks like. So it fits almost exactly there. The only difference in this case is we took out that piece from both sides, that x plus 2 and x plus 2 from over here. Well, we can't have a denominator equaling to 0. So the way we could get that denominator to be 0 is if x were equal to negative 2. That's why there's a big hole right here at x equals negative 2, because it's a point of discontinuity. And by that we mean the line would continue through there, just everywhere around there except that point. It is discontinuous at that point. So let's see how this rational function looks like. We have f of x equals 1 over x plus 2. Now in this case we can't take out any fractions. But again, we don't want the denominator equal to 0. How we would do that would be x equals negative 2. Negative 2 plus 2 would be 0. We'd have 1 over 0. That would be undefined. So we can't let x equal negative 2. Well, in this case, because that factor didn't cross out from the top and the bottom, it becomes what we call a vertical asymptote. The vertical asymptote is this imaginary line, x equals negative 2, where the lines or the function gets very, very close to, but will never actually touch. Now notice there's also a horizontal asymptote here at y equals 0. And why that is because if we called f of x, if we set it equal to 0, 0 equals 1 over x plus 2, this will never ever happen, because 0 can only occur if 0 is in the numerator and something else is in the denominator. So like 3 or 8 or 83. 0 divided by something else would equal 0, but unfortunately our numerator is not 0. Our numerator in this case is 1. So we'll never get the function to come to 0. That's why there's that horizontal asymptote that it looks like it's approaching, but will never touch. So again, a hole or point of discontinuity just occurs when in our function we can take out common factors. Whatever the x-coordinate that causes the common factor to be 0 is, that's where the hole is going to occur, at that x-coordinate. Vertical asymptote is the imaginary line where the function gets very, very close to but will never touch, and we can find that by finding a factor in the denominator that we would set to 0. Whatever that x value is, that's where the asymptote is. And a horizontal asymptote is, again, a horizontal line where the graph will never ever get to. It gets very, very close to, but just because of the way the equation is set up, it will never actually be able to be equal to that amount. So let's see if we can find where some of these holes in these asymptotes are found. So in this case, if we have x squared minus 4 over x squared plus 5x plus 6. And we just want to determine where it's undefined. So we'll set these, find the factors of this, x plus 2 and x minus 2. And factors of the bottom, we would have x plus 3 and x plus 2. So we would say that it's undefined at x equals negative 3 and x equals negative 2. So we plug negative 3 in here, that would be 0. Negative 2 in here, that would also be 0. But x plus 2 and x plus 2 can cross out. So we would say that the x minus 2 is actually, in this case, going to be a whole. And that the x equals negative 3 isn't a whole, it's an asymptote. So those are our values of the wholes and the asymptotes for that graph. So let's try it again over here. First thing to do is factor it down, difference of squares, x minus 3, x plus 3 over x plus 3 and x plus 5. So again, we know that we're undefined at x is negative 3 and x is negative 5. Those are the two values. X plus 3 and x plus 3 we can divide out. So we'd say we have a whole at x equals negative 3, and we have an asymptote at x equals negative 5. All right, moving on. If we want to learn how to actually graph these functions, there are a few steps we need to follow. First is obviously find any wholes and then any vertical asymptotes. So, looks like we're already factored down as much as we can. So the only place where we're going to be undefined is where x is negative 1. Now, since we didn't actually take out any factors, x equals negative 1 is going to be considered an asymptote. Oops. Okay. Next thing to do is find our x and y intercepts. So the x-intercept, let's start with the y-intercept, is where x equals 0. So 0 over 0 plus 1 equals 0 over 1 equals 0. So our y-intercept is just 0. Then to find our x-intercept, it would be where y is 0. So we'd say 0 equals x over x plus 1. We can call this 0 over 1 and cross multiply to find this. X plus 1 times 0 is still just 0. 1 times x is x. So it would solve out at where x is 0. So the only x-intercept is 0, the only y-intercept is also 0. So let's draw out what this looks like so far. We know that there are no wholes, but that we have a vertical asymptote at x equals negative 1. So that's going to go right here. And we know that our x and our y-intercept is the point 0, 0. So we're most of the way there now. The only thing left to do is make a chart, x and y. And we'll just find values that are going to be fairly close to what we have here. So like negative 3, or negative 4, negative 3, and negative 2. We don't have to use negative 1 because that's our asymptote. We've already found 0, so we'll do 1, 2, and 3. Well, if we plug negative 4 in for our x value, that would give us negative 4 over negative 4 plus 1 would be negative 3. The negatives cancel out. We'd be left with 4/3. If we use negative 3, it's going to be very similar. It will be 3/2. Negative 2, following along that pattern, would be 2 over 1, or we could just say, in that case, delete that, and it would just be 2. Now, if we do 1, it would be 1 over 1 plus 1 is 1/2. 2 would become 2 over 2 plus 1 is 2/3. And similarly, 3/4. So these would be our values. So the only thing left to do is plot these. 4/3 is the same as 1 1/3. 3/2 is the same as 1 1/2. So to plot these ones, -4 in our x value and 1 1/3, just about there. -3 and 1 1/2. -2 and 2. On the right side of the asymptote, we have 1 1/2, 2 2/3, 3 3/4. So it looks like we're getting bigger there. We know that we're going to get very, very close to this vertical asymptote, but never touch it. So we would say then that our line looks something like that. And it looks like it's going downward. Same thing here, it's going to get very, very close. And if we connect these dots, again, it looks like it's kind of swooping downwards this way. If we look at how these are acting, they're going to go forever on straight in that direction. But again, because we have x over x plus 1, we're never going to actually get it to be 1. So if we set f of x to 1, 1 would have to, we'd have to have the numerators the same as the denominator. Remember, 1 is something over itself. Well, x and x plus 1 are never going to be the same value. So we can never get 1 to be the same as those. That's why our horizontal asymptote would be set at 1. So this is how our graph would end up looking. For our last one, remember, the first thing to do is factor it out. So we would get x plus 1, x plus 4 over x plus 4. These two cross out, so it looks like we're going to look like the graph of y equals x plus 1. So that helps us a lot. We already know then that there is a hole right here at x equals -4. There are no asymptotes, or at least no vertical asymptotes. The y-intercept of the function set x equal to 0. If x equals 0, we would be at 1. If y equals 0, then x would be -1. And again, we can just look at this function because it's going to look just like that to find that. We don't really need an xy chart because we just know that it's going to be, again, this x plus 1 chart, only we're missing the negative, where x is -4. So we have our x-intercept here at -1, our y-intercept here. And again, that follows this line exactly. So we would continue right through there. Only difference is, wherever we have this -4 value, we would just need to put in a hole. So this is going to be the graph of our function.